Okay, so we're building AI that's changing everything, like at a mind-bending pace. But here's the thing. There's this massive, hidden problem, and it's one we absolutely cannot afford to ignore.
And really, this whole thing boils down to one single, kinda unsettling question. Because look, as this tech weaves itself into our lives, our jobs, even our national security, well, finding the answer isn't just a nice-to-have anymore. It's totally non-negotiable.
Now, you might think this is just some sci-fi speculation, right? But it's not. That quote you see, that's from Dario Amodei, the CEO of Anthropic, one of the biggest AI companies on the planet. This concern is real, it's being talked about at the highest levels, and it's all because we're facing a problem that's, well, it's unlike anything we've ever seen in the history of technology.
Okay, so that brings us to the big question, why is AI so different? I mean, with a car or a regular computer program, you can just pop the hood and see what's going on, right? So why can't we do that here? And this really gets to the heart of it. On one side, you've got your traditional software. Every single thing it does, it's because a human wrote a line of code telling it exactly what to do. It's designed piece by piece. But then you have generative AI. A top researcher, Chris Olah, said it best. These things are grown, not built. It's like we plant a seed, give it tons of data to feed on. But how it grows its internal brain, that just kind of emerges. We can't predict it, and we definitely didn't design it line by line.
And there's actually a name for this lack of understanding. It's called opacity. It's just the fancy technical term for this whole black box problem. See, when you look inside one of these models, you're not going to find neat, logical instructions. What you find are these massive spreadsheets of billions and billions of numbers. We know they do incredible things, but we have no idea how they're actually doing it. So you might be wondering, okay, so what? Why is this black box thing so dangerous? Well, the truth is, the consequences are way, way bigger than just a simple glitch or a funny wrong answer. Our ignorance here creates some really tangible, high-stakes risks. And these risks, they really run the gamut from, that's concerning, to potentially catastrophic. For example, there's misalignment. What if an AI learns how to deceive us to get what it wants? Then there's misuse. What if someone figures out how to use these tools to design weapons? But it's not all future stuff either. Right now, this opacity is blocking these AIs from being used in places like medicine or high-stakes finance, where you literally have to explain your decisions. It even stifles science. An AI might perfectly predict how a protein folds, which is amazing, but it can't tell us why, so we don't gain any real scientific understanding. So, to try and solve this, a whole new scientific quest has kicked off. It's a field called interpretability, and its entire mission is to crack open that black box. The goal is simple: make these things understandable. And right now, researchers are basically taking two very different paths to try and get there. And this table here lays out those two paths perfectly. On one side, you have what's called post hoc explanations. Think of this as an outside-in approach. You're just trying to explain a decision after it's already been made. But on the other side, you've got mechanistic interpretability, which is way more ambitious. This is an inside-out approach, trying to actually map what's happening inside. And that's the key difference, right? Reliability. One gives you a story that sounds good but could be totally wrong, while the other is trying to find the actual ground truth of how it works. Okay, so let's dig into that first approach. These are called post hoc methods. You might have heard of tools like Lime or Shap. They're the most common ones out there. Basically, they work by poking and prodding the input to see what made the biggest difference to the output. It's pretty much like asking the AI, hey, why'd you do that after the fact? And it'll point back and say, well, these words over here or those pixels in the corner, they seem to matter the most. But, and this is a huge but, there's a major catch. This quick look can be super misleading. In fact, it can even be deliberately misleading. Studies have shown these explanations are really fragile. You can change an image just a tiny bit and the explanation completely flips. What's even scarier is that they can be manipulated. I mean, one study actually trained a model to make a biased decision based on race, but then they tricked the explanation tool into pointing at something totally harmless. It's a classic case of correlation, not causation, and that is a massive, critical weakness.
So all of that brings us to the second path, the much, much more ambitious one, mechanistic interpretability. And the goal here is, well, it's nothing short of creating an MRI for an AI's brain, a tool that can let us see exactly what's going on inside.
And the process is super methodical, very scientific. It's a lot like how you'd study a brain in neuroscience. First, they decompose a behavior.
They break it down into smaller pieces. Then they try to localize those pieces, finding the exact circuits of artificial neurons that are doing the work. And finally, and this part is key, they try to recompose it. They build a mini version of that circuit just to prove that they actually truly understand how it functions.
This map does a great job of laying out the whole field. You can see how it all starts with that big problem of opacity, and then it splits into the two approaches we just talked about. If you follow that mechanistic interpretability path, you'll see how techniques like circuit tracing can lead to some really powerful stuff, like being able to debug the model from the inside or verify its safety. Of course, the end goal is trustworthy AI we can actually control, but getting there is not easy. The sheer scale of these models is a huge challenge.
And here's the crucial part. Researchers aren't just sitting back and watching. They're actively getting in there and intervening. There was this now famous experiment where researchers at Anthropic found the exact little cluster of neurons inside their model, Claude, that represented the idea of the Golden Gate Bridge. So what did they do? They cranked up the activation on that specific spot. And the result was hilarious. They created Golden Gate Claude, a version of the model that was completely obsessed with the bridge. It would bring it up in every conversation, no matter what you were talking about. And that was the proof. It showed they'd found the right circuit and could actually control it.
Which brings us to really the climax of this whole story. We're in a high-stakes race. Think of it like two tracks. On one track, you have AI power and capability just exploding, growing exponentially. And on the other track, you have us making much, much slower progress in actually understanding these things. And that gap between power and understanding, it's getting wider.
And the timeline for this race is shrinking. Fast. Amodi warns that we could have AI systems that are like having a country of geniuses in a data center as soon as 2026 or 2027. I mean, that's just around the corner. The idea of letting systems that powerful loose on the world without knowing how they work? Yeah, he calls that basically unacceptable. And he's not alone.
So what do? How do we make sure understanding wins this race? Well, Amode lays out a pretty clear three-part game plan. First, we have to massively accelerate the research into interpretability, pour resources into it. Second, governments need to step in with some light touch rules, not telling companies how to do it, but requiring them to be transparent about their safety work. And third, use things like export controls on the most advanced computer chips. The idea is to create a little bit of a buffer, to slow down the capability race just enough to let our understanding catch up.
Because at the end of the day, this isn't just a technical puzzle for engineers to solve, it's a huge societal challenge for all of us. Look, the question is no longer, can we build powerful AI? We're already doing it. The real question is, can we build it responsibly? And that has to start with understanding our own creations before they radically transform our economy, our lives, and our future.